Hello everyone, this is the second part of this problem, and for this second part we're going to find for the value of the integral from 0 to 1 of fx dx for k is equal to -8. And we're going to consider the family of functions fx is equal to 1 divided by x squared minus 2x plus c plus k when k is a constant. So to find for the integral from 0 to 1 of fx dx, we're going to put in k is equal to -8 into this function. So then we would have the integral from 0 to 1 of fx when k is equal to -8. And to take the integral of this, we're going to turn this into two fractions first. And we're going to use partial fractions to do that. So we have 1 divided by x squared minus 2x minus 8 here, which is equal to, if we factor the bottom, we can factor it with -4 and 2. So 1 divided by x minus 4 times x plus 2. And we're going to separate this so that we would have a divided by x minus 4 plus b divided by x plus 2. We're going to multiply this by x plus 2 and x minus 4 for this side, and also do the same for the other side. I kind of have to write that sideways, so if you can't read it, it says x minus 4 times x plus 2. And so we're going to work with these two. If we multiply this by x plus 2 and x minus 4, we just have 1. And that is equal to, we don't want to factor it, we're just going to multiply it. We don't want to factor it like that, we just want to expand it normally. With a, after we expand it, so we would have a times x plus 2, and then we're also going to factor it with b, x minus 4. And now we're going to try to find for a, the values of a and b. The way we're going to do that is we're first going to put in x as -2. So when x is equal to -2, we have, this would just cancel out as 0, and we would just have b multiplied by -2, -4, so -6 times b is equal to 1. And if we solve for b, we would have b is equal to -1/6. And then we can, so now that we have found the value of b, we have to find for the value of a. And we're going to put in 4, the value of 4 as x. Because then that would cancel out this, because it would just be 0. And we would only have 4 plus 2, which is 6, multiplied by a is equal to 1. Solve for a, and we have 1/6. Okay, we have found the two values, we have found the two values of a and b, and now we're going to put that into here. So we're going to come back to here, where we have the integral from 0 to 1 of, we're going to use this. This is our new integrand inside of our integral, but instead of a and b, we're going to put 1/6 as b, a, and -1/6 as b. And we would have 1/6 divided by x minus 4 minus 1/6 divided by x plus 2. And we have the x. Now we can factor 1/6 outside, or we can just take the integral, because it doesn't really matter. After we take the integral, we'll get this, and then we're going to put in 0 and 1. If we put in x is equal to 1 into here, we have, actually we're going to use the law of logarithms to simplify this more before we substitute our x values or the intervals in. So the law of logarithms says if we have a negative here, then we can turn this into a fraction. Oh, I'm so sorry. This is supposed to be plus 2. And therefore, we would have 1 over 6 multiplied by ln of x minus 4 divided by x plus 2 from 0 to 1. And now we can finally put in our interval or our x values. If we put in x is equal to 1 into here, we have 1 over 6 multiplied by ln of 1, so we would have negative 3 over 3, so that's just negative 1, but since we have the absolute value, we would just have 1. Subtracted by 1 over 6 times the ln of, if we put in the 0, we would have negative 4 over 2, which is negative 2, but since we, again, have the absolute value, we would just have 2. And we don't have to worry about this part, since ln 1 is just a 0. And now all we have left for the answer is negative 1 over 6 multiplied by the ln of 2. And that's our answer. Thank you for watching, everyone. I hope you understood my explanation, and have a great day. Bye. And watch the third and last part.